Hello everyone! Today we will review this one new amazing analog video transmitter from AKK. It is 5-watt transmitter with its own fan cooling system and with extended frequency bands. And there are a lot of words in description, so a lot of functionality, interesting facts proposed. So we will make some tests today. Let's go! So let's start unboxing with review. This is old 3-watt transmitter. This is a new 5-watt AC all channels transmitter. And this is just long range. And they look pretty similar, but actually there is a difference. Let's find out what is the difference. Who is who? And the answer is here. This one with a big shield is a new one, TX5000 AC, and this one without shield is the old one. Also, there are a few more differences here. For example, here we've got only one button, and on the old one we've got two buttons. And on the 3-watt I can see microphone, and on the new one, 5 watts, I don't see any kind of microphone. None here, neither in description. So, okay. What else can we see? What are the difference? Another difference is in connection. The new one has this device on the power supply wire, and this is Drossel, and as I remember, if I remember correctly, it should help us avoid extra jumps of currency. So also if we open in the user guide, we can see slow power on. The VTX will wait for 5 seconds before turning on power amplifier. So maybe it's related, maybe not. Anyway, this is an extra protection against high currency jump. Or also maybe it helps reduce some noise on the power lane. Probably yes, or maybe no, don't know. Okay, and let's compare user guides. What else? What other difference can we see? And we've got here it is. New one starts with the 25 milliwatts, and old one starts with 250 milliwatts, and this is a very important difference. Very often we need a small power, even in our case, even if we fly far away, we often may need the smallest power. For example, if we just configure anything and don't want it to overheat or overblast. Then what are the difference is in voltage support. The new one, voltage starts with 14.6 volt up to 28 volts, and suggested recommended 6S battery. And the old one started with 8 volts and suggests start with 2S battery. So this one no more support 2S. That's interesting. We should keep it in mind when testing. And the big difference in the frequency table. You can see that there are much more frequencies supported here in the new one rather than in old. And because of it, it actually supports not just more different values, it actually supports wider range, wider spectrum, and because of it you can buy two different antennas. It's not LHCP or RHCP. These antennas both write polarization, but this antenna is adjusted for lower frequency, and this is adjusted for higher frequency. So depending on which channel, which frequency you usually use, you should use one or another antenna. That's interesting fact. Okay, so time to test. And to check how it works, I have made this setup. I don't use smart audio for now, I will control it by buttons for now. And I've got this receiver, antenna, some camera that I've found, and configured to voltage like 6S. So turn on. Okay, it turns on not immediately, it needs some time to sync, as we read in instructions, so waiting for 5 seconds or for some time. You can hear that it works rather loudly, but it works enough good to keep it cold. By default it's 25 milliwatts, and on this power it doesn't heat almost at all. So a bit warm, but it doesn't heat up so good. Okay, and the next aspect that I've got, it's the frequency table. And unexpectedly I understood that frequencies from, for example, band A on this table does not match one band A that we used to on other tables and in any device. So if I use band A here, then I should check by the frequency, and according to the frequency I have to configure band O on this device. Oh, I've got loud sound from this power supply, so sorry. So the frequency band, if you configure it by button press and by this LED, it will not match typical channel band that we used to, so you have to validate the real value of frequency. Please keep it in mind. So here I have configured A1, and here I have configured O1, and this one has the same frequency. And now I can see it works. And to control this, it's controlled very simple. Single press of button, switch frequency, and you can see red LED jumps from one to another. It switches frequency channel 1, 2, 3, 4, 5 and so on. To change the band you have to make the long press. So long press, hop, blinked blue one, and now when I press I change the bands. So let me return back to the O1. Here it is. And now let's check the power consumption. 25 milliwatts, actually use 6S, 35 milliamperes, so it is about 8 watts of power. So to transmit 25 milliwatts it used almost 8 watts, and all these 8 watts are actually spent somewhere here and here. So but as you can see, the cooler works very well and it does not overheat. So let's try the maximum power. Long press, waiting for green to blink, green blink, and change the power. According to user guide, these two LEDs on the side have the maximum power. And what do we have? We have 1 ampere of usage. So if your motor uses 20 amperes, then 1 ampere is used only for VTX. And if we calculate 1, 0, 7, it's about 24.5 watts of power. So to transmit 5 watts, you need to spend 25 watts. So just this is a fact. And now it heats up, so it's uncomfortable to touch it. So let me switch it back to some lower power. Here it is. And what else I would like to say is that this misunderstanding with the channels, you have to check the real numbers. And I hope that when I use smart audio, I can just configure correct values, but it is something to check. Okay, configuration. In ports, I select corresponding UART, select VTX, TBS Smart Audio. Then video transmitter, and here we just use download from this web page, homepage of AKK, not home, but I will leave the link in description. We download the configuration table, go here, press load from the file and upload this parameter. And please pay attention that here we've got power table with the numbers ID 0, 1, 2, 3, 4, 5, it's valuable. This is just text, but this one should be 0, 1, 2, 3, 4, 5. And this table of configuration. And you can pay attention that this table does not match what we have used to, as I already told. So the typical, for example, typical A1, it's 5865. And here we've got different. And even if I manually set these values to the common one, it will still work with its internal frequency table. I don't know how to work around this, but I have found another workaround. So I just enter frequency manually. So I go here, find frequency I would like, for example R1, I copy this frequency and enter it here, and in this case the expected frequency will be applied. So please pay attention on this, you will need manual frequency set. If I will have any updates on this configuration, I will leave note in the comments. And the final one, not the final one, OSD, I have set NTSC for myself. And another interesting thing that I have configured the 6 position button to one aux channel, and here in CLI I have entered the set of values. Joshua Bardwell has a very detailed description of how this works. You can use this table to control your power from your remote control. So now I've got my 6 position button switch on remote sets different power values for me. It's very good for testing. And that's all about the settings. Okay, and now we've got test. So I have started with a 25 milliwatts, which is very small. I have to switch, and surprise, surprise, when you're switching, you got a loss of the signal for some moments, half second up to 1.5 seconds. So please keep it in mind and do like I have done. I have switched it in angle mode to avoid drone crash. And now let's go and check how far will it go. Go, 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 go. Oh, and actually I've got the field ends and there is a houses in front, so I will not go there. And I have to find another place to test. And let's test it using my car. please note that when you're driving car, you can drive not so far like when you're flying. It's just because the ground is very close and the quality of signal will always be less. And on the 5 watts, I have managed to drive 1 kilometer and weigh 250 meters. It's without obstacles, and it is very good result, because when previously I have tested it with Aliexpress 2.5 watt transmitter, I have managed to drive only 450 meters. So this video transmitter allow me to go more than 2 times more far. And as you can see, the quality of signal remained rather good up to the end, up to the maximum distance, which is very good. Okay, so what is conclusion? What are the pros and cons about this transmitter? And first that we are interested in, it's the quality of the signal, especially at the maximum power. And I have no negative things to say. It works at maximum power level very good. So I have tested it at the car, not at the FPV drone, but at the car at the sunny, very hot day. And it has stayed for some time just under the sun without any wind. And it has survived at maximum 5 volts or 5 watts transmitting power. So you should not be afraid that it will fire up, that it will burn itself out. It stays very stable, and that's very good. At the same time, the quality of transmission remains very good. So, you know, when you're trying to use some cheap video transmitters at maximum power, if you don't have enough cooling fan, then the power starts going not so good and you got losing signal or whatever. This one works enough stable at maximum power and medium power, so, and this is the main up to me. Next, extended frequency band. It is a plus and it is a minus. It is a plus because it covers much more frequency range than we ever used to, and we've got much more variability. And the minus is that actually it conflicts with Betaflight. Betaflight does not support such wide frequency range. This is why developers of AKK had to hard-code these frequency bands, and they had to make it different against common frequency bands that we used to. So channel A1 on this will not match channel A1 at your video receiver. And you may tell that it is bad, but actually it can be solved or work around. For sure you can use auto search of band on your receiver, but if you don't want to use auto search, if you need some specific frequency, you always can use Betaflight manual frequency set. So I have set frequency manually to the values that used on R1, and it works well, and I've got the expected frequency on my receiver. So this problem is solved. The power switch. There is an aspect then when you switch power when you are flying, you will have about half second and 1 second signal, maybe even signal lost. So before switching to another power level, you would better switch your drone to horizon mode and let the drone hover while you're switching, just to not lose your drone if you unexpectedly switching power when you're doing some acro tricks. Who makes so, I don't know, but please be aware that switching the power may require some half seconds or 1 second. And overall, no, another one thing. Two different antennas that are configured for two different frequencies. It's a very good solution because each antenna has its own characteristics, and there is almost no possibility to get one antenna that would be with a good parameters for all this long frequency diapason. This way they have just simply made two different antennas with frequency about 5 and frequency about 5.8. So this is a good solution, and you should pay attention and use this one antenna that you configured your frequency to. So in general, I believe this is a very good solution for high power and compact video transmitter. So thank you and have a nice flight. See you.